want to determine outliers. So there's two different methods of doing this. One is by using a normal distribution, because if we can put our information on a normal curve, then we'll know that outside of those two standard deviations would be considered outliers. And then the other way we're going to do this is a statistical calculation to find a z-score. And so we'll do both of them. So we have this set of data here. These are the top 30 people in terms of net worth and their ages, also where they work, and generally what country they live in or call home. And so we want to use the following data to find the ages, find the ages that are considered outliers. And then we're also going to look at net worth. So you would put all this information, these 30 pieces of information, into the calculator. And again, we need to know what the mean is, and we need to know what the population standard deviation is. And so by doing that, you end up with a mean of 67.43 and a population standard deviation of 15.54. And again, these are years old in terms of that. And so you can double check that. You can put all that information in and make sure you're doing that correctly. And so now we're going to use that information. And so since we're going to determine ages that are outliers, using the normal curve might be easier, because we can quickly write down each one of these values. So we know that this is 67.43. And then from there, we're going to add and subtract our 15.54. So we just take our 67.43 and we're going to add 15.54. We get 82.97. And we're going to do it one more time, because all we need is two standard deviations. We don't have to fill in all three of them in this case, is 98.51. So we know that a 99-year-old or older, it would be an outlier. Now if we go the other direction, so now we're going to start with 67.43, and this time we're going to subtract our 15.54, and we get somebody that is 51.89 years old. And then we're going to subtract one more time, and we have 36.35. So somebody that is younger than 36 years old is an outlier. All right, so let's go and look through our data and see if we have any 99-year-olds or older, or 36 and younger. And kind of scrolling through our data, does not look like we have some 39-year-old, and nobody 99 and above. So it looks like all the ages are considered normal. Now, for the z-score method, let's suppose, let's just take the last person, John Mars, and we want to find out whether his age is an outlier. So you take the data value minus the mean. Remember, this is mean, and this is standard deviation. So let's take this 87-year-old. So we want to know what the z-score is for an 87-year-old. And so we're going to take 87 minus the mean, which is 67.43. So essentially, we're trying to figure out where this person would fall, divided by the equal partitions of 15.54. If this z-score is greater than 2 standard deviations, then we know that this person is an outlier. So when we compute this, and we can just go to Desmos. See if I still have Desmos up. Doesn't look like it. Okay, I'm going to leave my normal distribution there just because that's what we're doing. I'm going to hit the divide key first. So division, so that gives me that fraction bar. And now I have the 87-year-old minus the mean, which was 67.43. And then we're going to put the mean, the standard deviation on the bottom, which is 15.54. And we end up with 1.26. So this equals 1.26. So 87 years old is normal, or you can say it's not an outlier, because the value is 1.26 standard deviations from the mean, which is not greater than 2. Not greater than 2 standard deviations. All right. If we look at the data, let's look at the billionaires. So we have $230.2 billion is Elon Musk, and we have John Mars at 39.4. But if we look at this data, we can kind of look at, so here's some 30 to so here is where it breaks off. So we have anywhere between 39 and 95 million. And then we have this 100. So we have 100, and then we have like 117. And then we have this next kind of group. So it looks like a lot of the data falls under $100 million. So if we were kind of looking at a histogram, it might be that these two people are pulling the graph to the right-hand side, to the higher end. Okay, but so we're going to see whether Elon Musk is his gross, or this 225.6, maybe, or even for that matter, maybe Jeff Bezos. So let's see using the z-score. So because all I need to calculate my z-score is I need to know the mean and I need to know the standard deviation. All right, so with all that put in again, so we calculator gives us $88.09 billion is the mean. And the median, or the standard deviation is 47.93. So $47.93 billion. And if we want to know if, so actually, let's see, we want to know if, what values might be above that. So we want that will be outlier. So method 2. So we're going to use a z-score. We're not going to create a normal distribution, although you can. I want to know if my standard deviation is bigger than 2. So I want to know when 2, I want to know what scores, so what data points, what data values, minus my mean of 88.09 divided by 47.93. And so the first thing I need to do is get rid of the division. So I'm going to multiply 47.93 times 2. And so we have 95.86. That equals D minus 88.09. Now I'm going to get rid of this subtraction of 88.09, and I'm going to add that. And I end up with a data value of 183.9 $1.95 billion gives me 2 standard deviations. And so 2 standard deviations, 183.95. Anything beyond 183.95 is considered an outlier. So 183.95. So these two values are outliers. Everything else is considered normal.